Hello everyone, my name is Bigtron. In this video, I will give an overview of ETLook model, which is a model generating WaPOR data products. You will learn about the model development, theory, and implementation of ETLook. ETLook model uses satellite data and climate data to generate several WaPOR data layers, including reference evapotranspiration, evaporation, transpiration, interception, net primary production, from which the biomass production and water productivity are also derived. The evapotranspiration model of ETLook is based on Penman-Monteith equation, while the biomass model is based on C-fix model. ETLook model is independent of sensors and can be run at multiple spatial scales. The model was first introduced in 2010 and published in a scientific journal in 2012. In 2017, ETLook model is further developed to produce WaPOR data by ELIF and in collaboration with FAO. For operational data production, which means producing data at near real time for monitoring purpose, certain modifications have been made to the original model. The key principles of ETLook model is to solve Feynman-Monteith equation separately for vegetation and soil to calculate transpiration and evaporation. Besides the net radiation and soil heat flux, soil resistance, canopy resistance, and aerodynamic resistance are derived from satellite data and climatic data. Soil resistance is a function of soil moisture content in the topsoil. Canopy resistance is a function of LAI and four-dimensionless stress function based on Jarvis-Stewart model, temperature stress, vapor pressure stress, radiation stress, and stress related to soil moisture content in the subsoil. Aerodynamic, canopy, and soil resistance are a function of wind speed and surface roughness and corrected for unstable condition through an iterative procedure. In case of biomass model, the net primary production is derived using C-fix model with some modification. A reduction factor for soil moisture stress is added, and land cover light use efficiency is classified within ETLook model. ETLook model was first implemented at field scale and river basin scale using soil moisture estimates from AMSRE, a passive microwave sensor, meteorological measurements from ground station, and surface reflectance from MODIS sensor at 1 km scale. The soil moisture estimate without scale from 25 km AMSRE data. For WaPOR data production, the goal is to generate a consistent dataset at continuous scale near real time. Therefore, several changes are needed. Firstly, soil moisture estimates are derived from a soil moisture model to remove the need of passive microwave sensor. This enhances the spatial resolution and temporal continuity of the datasets since soil moisture estimates can be retrieved from normalized difference vegetation index and land surface temperature data. Moreover, the meteorological data are obtained from climate model or climate reanalysis, which removes the need of ground-based measurements and generates WaPOR data consistently. Finally, surface reflections at visible and near-infrared bands from multiple sensors are used to produce WaPOR data, allowing it to produce multiple spatial scales data. In general, the workflow of WaPOR data production includes three major steps. The first step is pre-processing input data from multiple sources. The second step is gap filling and harmonization to obtain the best values for each day for the whole WaPOR area. In the last step, ETLook model is run with intermediate datasets to create decadal WaPOR data, which is then aggregated to monthly and yearly level. Since producing WaPOR at high resolution globally is very time-consuming and computationally expensive, WaPOR data at level 3 is only available in some regions. However, WaPOR users can now use the pyWAPOR to calculate evapotranspiration, net primary production, and water productivity at high resolution for study areas that are not covered in WaPOR database. The pyWAPOR package is an open source Python package that runs ETLook model and allows customizing input datasets and parameters. Users can also run ETLook model for their own data and experiment with different model parameters. The pyWAPOR package also includes tools to download and prepare inputs for ETLook model. It supports several satellite data sets, which are used to produce WaPOR data. In the following lessons of this unit, you will learn more about the submodels of ETLook. The current ETLook model has three submodels: root zone soil moisture, evapotranspiration, and biomass models. This graph here shows the relation of ETLook models and WaPOR data components. The soil moisture model generates relative soil moisture content from satellite data, which is then used as input for both evapotranspiration and biomass model. The outputs from ETLook models are reference ET, relative soil moisture content, net primary production, transpiration, evaporation, and interception. NPP, transpiration, and AETI are used to calculate other WaPOR data layers, including total biomass production and water productivity.